exercise 4.13, mostly on the instruction sequence A. So your homework is to complete the same question for instruction sequence B. One thing I need to explain is no forwarding mechanism. So the architecture does not have any forwarding mechanism. So there is a data hazard, and in that case there is a possibility of a software solution when the compiler is compile the program, and when it identifies in the data hazard case, the compiler simply insert a no operation to eliminate avoid the data hazard. And another terminology is ALU forwarding. There is no clear definition in the textbook what that means. But ALU forwarding is, if you look at the figure on the top right corner, the forwarding can happen from the output from the ALU to the subsequent instruction, or the next instruction. So I consider it is an ALU forwarding. And on the other hand, at the bottom, in case of load word instruction is the first instruction, and the new value of destination register is coming from the memory module rather than ALU module. So in that case, I consider that as memory to ALU forwarding. So the top one is ALU forwarding. The bottom one is memory to ALU forwarding. So indicate the dependencies. In this case, register 4 between the load word instruction and addition instruction. Note that register 16 is not data dependency, because stored instruction register 16 is not the destination register. Question B, assuming there is no forwarding, what happens is that the stored instruction and load word instruction, at cycle number 6 in write back stage, load word instruction produces the newer value, write back into the register 4, newer value of register 4. On the other hand, addition instruction needs reading the newer value of register 4 at the ID stage. So, if there is no forwarding mechanism, you actually can start the addition instruction in cycle 5, which means that you have to adding 2 no operation in between those two. So this is the answer for question 2. So question 3, when there is a full forwarding mechanism, the load word instruction, although the newer value of register 4 is written in cycle 6, the value itself is available after cycle 5. And likewise, addition instruction needed at ID stage, but actually it is needed as long as it available before cycle 6 and execution stage. That's fine. So accordingly, we just need a one no operation in this case. So with the forwarding, because of that, we just have 8 cycles to complete those 3 instructions. And without the forwarding, because we need the 2 no operation, is becoming a 9 cycle. So multiply with the cycle times, 300 picosecond and 200 picosecond. So that is the total execution time with and without forwarding mechanism. So question number 5, in case ALU forwarding is only available, so the memory module to ALU is not there. So in that case, this is the same as the no forwarding case. So which means that we need to have a 2 no operation. And since there is a forwarding mechanism, I assume it is a 300 picosecond. So 9 cycles multiplied by 300 picosecond is 2700 picosecond. Okay, this is exercise 4.20. As before, I'm explaining for instruction sequence A. Your homework is to complete for instruction sequence B. One thing I need to note is that the 6-stage pipeline. So in this case, the memory is divided into 2 stages. So that's IFIDEX M1, M2, and write back. So that's a 6 stage. As I mentioned earlier, pipeline is not just a 5 stage. Some architecture take a 2 stage pipeline. Some architecture take the 10 stage pipeline. So all the dependencies, the addition load word instruction on register 1, addition and second load word instruction on register 1, load word instruction or an OR instruction on register 2, a second load word instruction and OR instruction on register number 1. Without forwarding, all those 4 cases are data hazard. However, with the forwarding, forwarding mechanism resolve those first 3 cases, and there is only one case. The last one is actually the data hazard, and you have to stall the 1 cycle because of that. The number 3, in case of a 6-stage pipeline architecture, without the forwarding, what happens is that addition instruction, register number 1 is available, is written back at the write back stage cycle. On the other hand, the following load word instruction, it is reading register number 1 and ID stage, and so therefore you need the 3 no operation between those 2. And the second load word instruction and OR instruction, likewise, it is written at the write back stage and reading at the ID stage. You also need a 3 no operation between those 2. With the forwarding mechanism, you just need to see when the value is available and when it is actually needed. And you can easily see that for the first case, we don't need no operation at all. So forwarding mechanism resolve the case. But on the second case, between the load word instruction and OR instruction, if you look at that, you can easily see that you need a 2 no operation between those 2. So first, the data forwarding happens between the first and second instruction on register number 1. The register number 1 from register file is -1. Register number 1 from addition instruction is just 30. Question number 5, hazard detection unit is implemented, but the forwarding is not implemented by mistake. And so newer value of register 1 is available after memory stage, but the OR instruction take the register number 1 from register file by mistake. So here is the result, and you need a 2 no operation between that because of that.